Welcome to video 2. In this one we're going to talk about the VEX pneumatic system. So the first thing we have here is the reservoir. This is the part that's going to hold all of the pressurized air. We attach a bicycle pump to this fitting down here, and we can pressurize it to 100 psi. That's really how much air we can pump into that. This part right here we don't need to worry about. That's basically like a different way of charging the system with a bicycle pump. For our system, we're going to use the first one that's attached. So this part you don't have to worry about. Coming on down the line, this next part is a switch. You can arm or disarm your system. Again, I don't believe I have one of those. It's not really necessary, to be perfectly honest. Coming on down the line then, we have our regulator. What the regulator does, you can turn this little dial and you can limit how much of that pressurized air gets sent on down the line. So you can think of it as a conservation means, some way to prevent the thing from, releasing all of its air too quickly. As we continue to follow the line, we come to a splitter. The splitter is in case you want to run two rams or two cylinders. So coming up, we'll follow the bottom one. This next part right here is the solenoid. A solenoid is a switch. It's a gateway, if you will. So it either allows air to pass through it or it doesn't. Now the solenoid itself is attached back to the microcortex. It goes into a digital port because this is a on or off scenario. There's no analog with this. It's not like you can just half open the valve. Either the valve is open or the valve is closed. And notice how this is set up. The input, or the incoming air, goes to the bottom of the solenoid. The output goes to the top, and there's two fittings on the top. Now for our system, we don't have the double action cylinders. We just have a single action cylinder. So this line right here is not needed. Basically, when the air comes through this part, it pushes the ram on the cylinder out. And then once it's out, it stays out for this setup. And then this line, when air comes through this one, it pushes the cylinder back. For us, we don't need that because what we have is a spring-loaded cylinder. So instead of using air to bring it back, we have a spring, which I think is a little more efficient. So that's really all there is to it. You just have to make sure that you have nothing plugged into this port on the solenoid, and it's good to go. And what's nice about this, if you get it wrong, all you have to do is just change the fitting around. It's a really easy system to use, to be honest. Now for some specifications. So the reservoir, we got the length, the diameter, the cylinder, all that stuff. And some things that we want to take a quick look at. First off, the diameter of the reservoir. That is important because remember, our equation we have the difference in the area. So the way we calculate area is, pi r squared. So we need to take the diameter, cut it in half, so we get the radius, square that, and multiply it by pi. And that gives us the area for the reservoir. Similarly, we have the cylinder bore. Now, bore is the same thing as diameter. So once again, we can use the diameter, cut it in half to get the radius, square it, times it by pi, and we get the area of the cylinder. And we can also see that the maximum pressure that the cylinder can take is 100 psi. For the most part, we can get right around 45 strokes from the reservoir, jumping from 100 psi down to when it's depleted to right around 25 psi. The output force, we can calculate the output force, and when we do, we see that it's right around 12 pounds. So here's how we can calculate that output force. Pressure is force divided by area, so force equals pressure times area. So the pressure is 100 pounds per square inch. The area, so again, if I take that bore and divide it by 2, so I have pi and then r squared, so the bore, which was 0.39 inches, I divide that by 2 squared, so you see the pi r squared, and then when I multiply all those numbers together, notice that the square inches go away and I get 12 pounds. It's like 11.95, but we can round it up to 12. So it's pretty simple. All right. The next thing I want to show you is how to program this. So we need to use a while loop. And it's very much just like a button. So we're going to use an if statement. So let's say we have it plugged into the sensor. What you would want to do in your sensor setup, just whatever port it is, just name it solenoid or something. So the if statement, if the vex RT button 6U is pressed, so double equals 1, the sensor value equals 1, that activates it. Else, the sensor value equals 0, so it doesn't. So it's a very, very simple code that you can use, and you can put it in anywhere. If you don't want to use solenoid, I believe it's digital, so DGT 1, I think, or wherever you plug it in. We can take a look at what port you plug it in. All right, pretty simple stuff. So that concludes our pneumatics unit.